I think that there was a small, was there a mistake concerning the resolution? Should it be in kilometers or in square kilometers in your?
It is in kilometer, yeah.
Okay.
Spot on.
So that's easy. That's easily solved. Second question: why did you select only the data from one combination of
Yeah.
GCM and RCM? Could it be interesting to study the diversity of future possible climate with the use of several combinations of these global and regional?
Yes, so he's referring about the combination of global circulation models and regional climate models. So we had to choose between, considering the cities that we want to analyze and that we wanted a resolution of at least 25 kilometers and 3 hours frequency, we could choose between 3 combinations. And actually, we chose the model that, according to literature, performed better compared to observations. So we just chose the one that was, let's say, predicting the medium, predicting better compared to observations. But it's true that it will be also better to compare with prediction from multiple models. We had to choose one because of time, let's say, limitation, and the fact that we wanted to analyze many cities. And so that's why.
Okay, I hope this is what people expected. Question number 3. So why did we use the RCP 8.5 scenario? So
yeah. So well, this was also it has been discussed a lot. We had, if I remember well, like 2 to 3 meetings discussing what was the best scenario to adopt, because it is true that we could have also analyzed an intermediate scenario, the RCP 4.5. But in the end, we decided that for 2 reasons, it was okay to go for the worst case scenario for the Annex, because on the one hand, we wanted to, the aim of the Annex is to assess the resilience of cooling solutions. So we had to test the, let's say, extreme events, the shock, the maximum shock that buildings could have to withstand in the future. And also because actually since when the 5th assessment report was published in 2014, the actual climate has shown that we are going on the worst case scenario path. So the prediction of the worst case scenario are aligned with the actual observation of climate so far. So based on this, based on what we wanted to assess, we decided that it was very important to assess the worst case scenario. Then, of course, the intermediate scenario also it's useful for the person who asked the question to assess a more operational, let's say, energy use of buildings, but also again for a matter of limitation of time and resources, because we wanted to analyze many cities and many periods. We had to choose the most important scenario for the purpose of the analysis.
Yeah, true. And we design our buildings for, let's say, 100 years. So, okay. Yeah. So now question number 4: are you planning to publish the data sets for other RCPs scenarios?
Not for other RCPs. We are going to publish, we are going to publish the weather files. So the typical meteorological years and the extreme heat waves, the weather file containing extreme heat waves for the 3 periods and all the cities, and also the 20 years bias adjusted data, Harvey data, but for the worst case scenario. On the other hand, we are also publishing the codes that have been used to perform the bias adjustment and the extraction of the Cortex data. So the methodology can be applied to other scenarios and cities, because these data are available from the Cordex platform, but of course they have not been, they are not bias adjusted. So if anyone is interested in replicating the methodology, it will be possible if they can find observations, at least 5 years, but better 20 years of observational data to perform the bias adjustment using a code that is performed in R, so it's easy to apply. But we won't generate more data. These are the data that have been generated.
Okay, and the last question, so concerning the wind speed, did you calculate, use the wind speed for direct data models, or how
Okay,
is it
so
calculated?
We use the wind speed data from the model, but I think that is one of the variables that was actually that has the strongest bias, and also if I've shown quickly the results of the bias adjustment, but using observations, at least we could have a more realistic trend, let's say, of wind speed, assuming that this is the wind speed in a weather station located outside of a city. So we have compared all these climate projections from considering observational data from airport weather station. And so, of course, the wind speed then will be strongly modified by the surface, by the buildings in city. It will be completely different. But for now, we have just, let's say, provided data according to models for a location outside the city regarding wind speed.
Okay, thank you, Agnese. This your questions. We continue with INIVE. So first, why is mechanical free cooling performing worse than natural ventilation in future typical meteorological years?
Thank you, Philipp. So just before to answer the question, I just wanted to emphasize the fact that to produce and assemble the weather files, it was a tremendous work from all the institutions, because almost nobody had knowledge in climatology, and it was a lot of, we did a workshop for every institutions to produce the weather files, and it really was a lot of work. So we would have loved to make more data with other models and RCP scenarios, but it was already a lot. And to answer the question, I modeled the case study building with Energy Plus, and for natural ventilation, I used the airflow network. And in my building case study, I had very large windows, so the airflow was higher by the windows than by the ventilation ducts, because I chose a maximum airflow of 3 air change rate in the mechanical free cooling, and in the natural ventilation, we could see that the airflow rates were much higher. So that's why it performs better.
Mm-hmm. Okay, and the second question about heat wave in India. So why should ceiling fan not be used at the higher temperature of 35 degrees? I think you mentioned this. And
yes, so I mentioned this, but I'm really not an expert on this. But it's when we're talking about health risk, it can be a problem for, especially for vulnerable people, and using ceiling fans at high air temperatures can cause dehydration for old people, because they have not the same thermoregulation than young and healthy adults, and also because when the fan has a strong effect on the skin temperature, and at some point, if the skin temperature goes above the air temperature, then the ceiling fan has no effect. So we could see this from thermophysiological models, and I've seen this 35-degree limit in literature. I don't know if it's a fixed limit, and I think more research should be conducted on this, but just to keep in mind that at high temperature for vulnerable people, it might not be advised. That's it.
Yeah, I think yeah, I remember our colleague from Canada, Abdel Aziz Lawadi, who explained this, and it was, I think, mainly referring to vulnerable people, like old elderly people. Okay, so and we move on to Ronan and Sang-hoon. So what is the time steps used in Energy Plus?
It's just six time steps per hour, 10 minutes.
10 minutes, okay. And for natural ventilation?
So
what natural ventilation model was used?
Yeah, we used zone ventilation, the wind and stack open area object from the Energy Plus. It can define the opening areas that considers the climate data, wind, and also altitude of the building.
So in your simulation, was the airflow calculated or estimated then?
So for the natural ventilation simulation model, so simply just we define the zone ventilation, the windows opening area, and then with dynamic the algorithms in the Energy Plus can calculate air flows, like something like infiltration.
Mm-hmm. Okay, and how can energy saving intensity for natural ventilation increase if the average outdoor temperature increases in the time?
Right, but in the future, the cooling energy consumption increases. So even though the hours can be reduced in the future, but amount of the savings are increased. That's why we have more cooling energy savings.
Mm-hmm. Mm-hmm.
Can that be answer?
Okay. Could you explain?
Yeah, Ronan, you can help anytime.
Sure. I think that this is something we've been asking ourselves as well, because it is intuitive that if the weather outside is getting warmer, natural ventilation might be a less successful technique.
Mm-hmm.
But I think that the issue is, imagine that you are providing your natural ventilative cooling largely at night. It may be that the air may still be cool enough outside at night to use to flush heat out of the building. But the daytime temperatures have risen, and so there are more hours of the year in which you are using air conditioning during the day, and you still are benefiting from the nighttime flushing of heat with natural ventilation. But the question is not a crazy one, and we asked ourselves the same thing. And I think that there's a question 5 for Sang-hoon.
Yeah, question 5. Yeah, could you explain the window scenario that you used? Okay, I just thought the windows were opened only when the internal temperature was greater than the external.
Yeah, in general, windows are closed when the outdoor air temperature is equal to lower than the heating set point temperature, not indoor air temperature, heating set point temperature. But also we did the cooling set point control for the cooling energy savings. But for the cooled scenarios, windows are closed when the outdoor air temperature is equal to higher than the cooling set point temperature. We don't compare indoor air and external air. We compare with the outdoor air temperature and set point air temperature.
Mm-hmm. Mm-hmm. Okay, so I hope I got this. We got all questions right. I don't see any.
I could add something about that 35 Celsius limit for fans, if anybody's curious, because our colleagues at the Center for the Built Environment at UC Berkeley and some of their colleagues have been working on this a lot. The short answer is that the existing recommendation not to use fans when the indoor air temperature exceeds 35°C is that you're turning your occupied space into a convection oven. However, some of the more recent research points out that if you are sweating, it still can be effective to use fans at these high indoor air temperatures because you will benefit from the evaporative cooling on your skin. So I think that some people want to change that limit. I don't know what the limit will be, but there's some work in that area.